I have something along the lines of one of those airline window panels that you sit next to inside of an airliner. And I have this panel modeled at a constant thickness all the way through. I'm going to go through today how we can work on making something like this that has these kinds of surfaces where you have some crisp lines in there that blend into something that's smooth, and how we just generally think about making surfacey kind of stuff. This is less a step-by-step and more just a run through how this is made and ways to think about making these kinds of things. So I'll get started by pulling up some sketches that will make this thing. So here I've got a series of sketches that I can use to make my top half of my loft, and I can mirror it to the bottom. Now please note, if you intend on having a lot of features that would cross that mirror line, you might have a model with better integrity if you do it all in one. So if you run into problems after mirroring, that could be part of it. Let's jump into this. Now our design intent is to have a constant thickness throughout the entire part. So perhaps I'll jump in and see what happens if I offset each of these sketches to a constant thickness. So that's what our loft looks like after we've gone through all of that work. I'll go ahead and accept that. And if I take a cross section of this, right, maybe I'll grab a plane, move it up a little bit. Apply that, and then I'll create a inspection, precise section right on that. You can see, yeah, that red looks like it's a pretty constant thickness, so job done. But here's a few points that I wish to talk about when using this method. First off, perhaps you have a model that isn't always going to be a constant thickness, even if you make your sketches, and of course it worked out great in this case, but perhaps you have some geometric features or curvature that make it really hard to maintain a constant thickness. I mean, you could make a bunch of guide curves and see how that works for you, but I think there are easier ways to do that, which is what we're going to go through here. Additionally, we were working with something that had a window. Can you imagine making that window in one loft? You would have to make a whole bunch of guide curves, and it would be kind of rough no matter what platform you use. So let's talk about other ways that make it far easier. And I'll do that now. Instead of worrying about having a constant thickness in all of my sketch profiles, let's just worry about getting one face right? And I'm going to choose this inside face. If I can get this inside section here correct, then let's say I am good to go. It sure is a whole lot easier just thinking about one face instead of the entire part. So, in order to achieve that, I can simplify everything else. I'll go into my lofting profiles and edit my sketches. And in this sketch, what I'll do is I'll take it down to this one face that I worked hard to define over here, and we'll remake the sketch. All right, so I just have this area here, and what I'm going to do is make two lines, and we'll go with something like 6. We'll make a line on the end here to there. We're going to go vertical and deactivate it, right? So that's way more simple than what I had before. Easier to sketch, more reliable. We're going to do the same thing on this sketch. And there's our loft. As you can tell, we still have this inside face going great. And then over here, we just have a bunch of extra thickness. And this gives us a few advantages, right? But first off, before I go further, I'll set this loft actually to be tangent. And I'll give this a magnitude of 20. We're working with a pretty large part, right? So we can afford to be normal to plane pretty well. Let's mirror this part now. And again, if you run into lofting errors, one thing to check is do it all in one loft and see if that helps any. Sometimes you can get a different part integrity. From here, how do we work on this window now that we have all this extra room? Well, I'll create a plane here. I like to create a plane, and I don't think it's required, but I just like to create a plane for visualization purposes that lies outside of my part with a direct line of view onto the part. I think it makes it pretty clear for the kernel what I intend to do as well. So I'm going to start a sketch on here. We'll go with an oval window, or an elliptical is perhaps a better way of saying it. Go with a vertical to our origin there. We'll make this a large window. From there to there is 12. So how would you like to have a 2-foot window on your airplane? Well, that's what we're going to do here because we are awesome. And then I'll make this something like 20. We'll reduce this. Would 24 work? There you go. I'll go with 21. And we'll deactivate that. That seems like you could fit a chair right there pretty nicely. We're somewhat in scale, though this is a very big window. And then we're going to go with a project. And say I'll project this distance of 2 in. Of course, we'll deboss that material. And we'll say OK. Next, I'll go with a fillet. We can go from this face. I'll choose this face as well. And let's see if it'll let me go up to 1. Not quite. There we go. I think 0.95 is perfectly good. I might even sneak up on it and see if it's just a rounding error that's holding me back. I'll go with 0.99. Yep, it's just a rounding thing. So we'll apply that. And you can see what we've done here, right? Imagine doing this all in a single loft. It went from not too bad to really hard to think about doing this in one loft. But since we broke it up into multiple steps, you can see how much easier our workflow is. And that's one of the biggest and best pieces of advice I could give you. When something isn't going to work or is just so incredibly overwhelming to do all at once, break it down into smaller pieces, one step at a time. Now, you're also going to point out that our panel is supposed to have a constant thickness. That was our intent from the beginning, and we have varying thickness. So let's go through a few ways to make that right. One tool that makes sure that we have constant thickness is shell. So let's use that. I'll take a shell feature here. Oh, there it is. And we'll say 0.125. And then I'll select this face to remove. And this face. And this face over here. And we'll accept that, right? So, oh, and it looks like I actually did miss a face there, so we'll go ahead and add that in as well. All right. So when I go to activate my precise section view, the shell basically guarantees that we have everything at a constant thickness just like we want. I want to go through another method of doing this though, because when you're working with surfacey features like this, sometimes you want to have more than one option. So let me delete the shell. And this time we'll go with surface and delete face. And of course the surfacing is available in professional and expert, if I recall correctly. And now that I've selected all the faces that I don't care about being constant thickness, I'll select OK, and of course we are taken down to an infinitely thin surface, which is really only a geometric reference like a plane or an axis. It's not, you never say, oh, I'm all done, and the surface is your finished product, right? Surfaces are just a means to the end. So we'll go with thicken, and we can thicken the surface back into a solid, which absolutely can be our finished product. And I'll choose my thickness. Of course, I can change my thickening direction. I can go from the middle, one side, or the other. And we'll say OK. And just like that, we've gone back into a solid with a thickness. And with my surface that's left over, I can go into my surfaces section here and simply hide it, or I can delete face if I want to be done with it in the tree. Delete face is not necessary. It adds some extra computation, but if you work with a lot of surfaces, sometimes it can be hard to remember which surface is which, and if you just get rid of it, the surface with delete face, then it's easier to keep track of which surface is which as you run back and forward in the tree. Next, I'll go with this plane here, create a sketch, and I'll do an offset. So I'll project my ellipse to the sketch, just like that. We'll go with convert to reference and offset. Let's say that I want my window hole to be about that size. I'll deactivate and extrude through all. And there, we were able to make a panel of constant thickness a lot easier than trying to do it all in one loft. We were able to use sketches in ways that we started completely straight down here. We added a curvature with sharp lines down here, and then back to straight, and that created some crisp lines in our profile. And we saved a whole lot of time than trying to do this all in one loft. We also have two different methods to achieve a constant thickness, and that really helps in the cases when you're going for constant thickness and one reason or another you're not achieving it. So hopefully that is helpful. Thank you for watching, and please subscribe to the Alibre channel.